All right, let's talk about JavaScript arrays. If you've ever found yourself writing a for loop to go through an array, you know it gets the job done. But what if I told you there's a much cleaner, way more powerful, and honestly, more modern way to do it? Today, we're going to level up from the basic loops and really master the built-in array methods that are going to make your code so much more readable and efficient. This is a huge deal in modern JavaScript, and it's key to writing code that's easier to debug and maintain.
So here's the game plan. First, we're going to officially say goodbye to the old for loop. Then we'll dive into the real workhorses, the methods you'll use all the time for iterating and transforming data. After that, we'll tackle a super important topic, the difference between methods that change your original array and those that play it safe. We'll look at how to find what you're looking for, and then, to wrap it all up, we're going to put everything into practice and build a piece of a real to-do app. Let's get into it.
Okay, first stop, it's all about upgrading our code. See, the goal isn't just to get something working. It's to write code that screams its intention from a mile away. We're shifting from a mindset of telling the computer how to do every little step to just declaring what we want to happen. It sounds subtle, but trust me, it's a game changer for writing code that you and your team can actually understand. And boom, this slide says it all. On the left, you've got the classic for loop. You know the drill. You have to set up an index, a condition, an incrementer. It's a whole ceremony. And on the right, a single, beautiful line using .for-each. It does the exact same thing, but its purpose is so much clearer. For each item in this array, do this thing. That is the kind of clarity and power we're talking about today.
Awesome. Let's keep building on that. In this section, we're going to look at two of the absolute most fundamental array methods you'll use day in and day out, .for-each and .map. They both loop over an array, but they have one, and it's a big one, critical difference.
First up, for each method. The way I want you to think about this one is as your do something method. You pull this out when you need to perform some kind of action for every single item in an array. You know, like printing it to the console or saving it to a database. But here's the most important thing to remember. For each method doesn't give you anything back. Its return value is always undefined. It just does the work and moves on.
Now, say hello to its very popular cousin, .map. This is your transform something method. You use .map when you want to take an array, do something to each item, and then get a brand new array with all the transformed items. So, if you've got an array of numbers and you want a new array with all those numbers doubled, .map is your go-to tool. It always returns a new array that's the exact same length as the original.
So if you ever get confused, just come back to this slide. The entire difference boils down to the return value. Do you need to just perform an action for each item? Use for each. Is your goal to create a brand new, modified array? You need map. If you can get this one distinction down, you are well on your way.
Okay, time to talk about something really important, mutation. Some array methods don't just return a new value, they actually change or mutate the original array you're working with. Now this can be super useful, but it can also be a one-way ticket to some really confusing bugs if you're not paying attention. So let's meet the usual suspects.
Let's run through the big 5 mutating methods. You've got .push and .pop, which hang out at the end of the array. Then you've got .shift and .unshift, which do their work at the very beginning. And then there's .splice. This one is like the Swiss Army knife of array mutation. It can add, remove, or replace elements from anywhere you want.
Now I know .splice can look a little intimidating, but this slide breaks it down perfectly. It's really just 3 questions. First, where do you want to start making changes? That's the start index. Second, how many items do you want to get rid of? That's the delete count. And third, what new things do you want to add? And that part's even optional. That's all there is to it.
Whew. Okay, after that warning about mutation, let's talk about the safe way to work. A whole bunch of methods in JavaScript are specifically designed not to change your original array. Instead, they give you a brand new one, leaving your original data completely untouched. Honestly, this is usually a much safer way to code.
And here is the classic example that trips people up. Do not confuse .splice with .slice. They sound almost the same, but they do opposite things. Remember it this way. Splice with a P is for permanently changing things. Slice with a C is for creating a copy. If you just want to grab a piece of an array without messing with the original, you want .slice.
This is it. This is the whole takeaway. Just burn this into your brain. When in doubt, slice is your friend. It gives you a copy and leaves the original alone. This is such a fundamental idea for writing predictable, bug-free JavaScript.
Okay, so we know how to loop through arrays, transform them, even mutate them. But a lot of the time, you just need to, well, find stuff.
So let's check out the methods that are built specifically for searching and locating data inside your arrays.
The simplest search tool in the box is .indexOf. It's super straightforward. You give it a simple value, like a number or a string, and it tells you the index where it first finds it. And if it can't find it at all, it just gives you back -1. This is great for simple arrays, but it's not so helpful when you have an array full of objects.
For those more complex searches, like in our array of objects, you're going to want to use .find and .findIndex. Now, they look almost identical, but what they give you back is totally different. .find gives you the actual value, the whole object that matches your condition. .findIndex, on the other hand, just gives you its position, its index in the array. Both of them are super efficient because they stop looking as soon as they get the first match.
All right, theory's great, but let's make this feel real. We're going to take everything we've just learned and use it to build a super common feature you'd find in any to-do list app, deleting an item.
First things first, let's look at our data. This is a pattern you'll see everywhere. We have an array, and inside that array are a bunch of objects. Each object represents one of our to-do items, and it's got a unique ID and a description. Simple enough, right?
So here's the puzzle. Imagine the user clicks the little trash can icon next to build an app. In our code, all we know is the ID of that task, which is 2. The question is, how do we find and remove only that specific object from our array?
And here's where it all clicks into place. We solve this with a simple 1-2 punch. Step 1. We use .findIndex to scan through the array and find the exact position of the object where the ID is 2. Step 2. We take that index, we feed it into our mutating.splice method, and we tell it, start here and delete one item. And just like that, problem solved.
So you see, the real takeaway here is that these array methods are like Lego bricks. They're cool on their own, for sure, but their true power is unlocked when you start snapping them together. We just combined .findIndex and .splice to create a delete function. You can chain and combine these things in countless ways to build really complex features in a clean, elegant way.
And that brings us to the end. We just built a delete feature by finding an index and then splicing the array. So now I want you to think about the tools we've covered. What about adding a new task or editing an existing one? How would you use methods like .push or .map to build out those features? That's your next step on the road to mastering this stuff.